The first intelligence report that reached General Heinz Guderian's headquarters in January 1943 contained production statistics that seemed to mock the laws of industrial physics and manufacturing possibility. The document claimed that American tank factories were completing M4 Sherman tanks at rates exceeding one vehicle per hour, suggesting manufacturing capabilities that violated every assumption about armored vehicle production and wartime industrial organization. "This must be Allied disinformation," Guderian muttered to his intelligence staff, studying photographs of Detroit Arsenal tank plant that showed assembly lines producing complete tanks with automotive efficiency. "No factory in history has manufactured armored vehicles like automobiles. These Americans must be building cardboard decoys rather than actual fighting machines." These were experienced German panzer commanders who understood tank production through years of precision engineering and individual craftsmanship that had created superior armored vehicles through systematic quality control and technical excellence. The concept of mass-produced tanks seemed to violate fundamental principles of military vehicle manufacturing that emphasized individual attention over assembly line speed. They had no way of knowing they were witnessing the greatest tank production program in military history, or that American factories would manufacture over 49,000 Sherman tanks while revolutionizing armored vehicle production through systematic abundance that would overwhelm German tactical excellence through sheer numerical superiority. General Heinz Guderian stood beside his command Tiger tank at Army Group Center headquarters, embodying German confidence in armored warfare superiority that had revolutionized military tactics through innovative panzer doctrine and technological excellence. As architect of Blitzkrieg strategy, Guderian represented German assumptions about tank quality triumphing over quantity through superior engineering and systematic tactical application. The German tank production that Guderian understood included precision manufacturing, individual craftsmanship, and systematic quality control that created superior armored vehicles through careful attention to engineering details and performance specifications. German factories produced tanks like precision instruments rather than mass-manufactured products, emphasizing technological excellence over production speed. Tiger and Panther tanks that German industry manufactured represented pinnacle achievements in armored vehicle engineering through sophisticated design, advanced metallurgy, and systematic development that created combat superiority over Allied armor. German engineering had solved technical challenges that produced tanks exceeding enemy capabilities through individual excellence. Intelligence analysis of Allied tank production suggested enemy forces remained limited by conventional manufacturing methods, resource constraints, and industrial limitations that prevented rapid armored vehicle expansion. German planners calculated that Allied tank production would require years to match German capabilities while maintaining acceptable performance standards. The strategic doctrine that incorporated German tank advantages assumed technological superiority would enable continued tactical dominance through superior vehicles and systematic crew training that democratic forces could allegedly never achieve through rapid expansion and mass production approaches. Economic calculations performed by German military planners revealed Allied industrial capacity divided between civilian automotive production and limited military requirements, suggesting resource limitations that prevented total conversion to armored vehicle manufacturing. Steel allocation and skilled labor appeared insufficient for massive tank production programs. Cultural assumptions about American industrial organization suggested inefficient production methods and competitive rather than cooperative approaches that would prevent systematic military vehicle manufacturing. German propaganda characterized democratic industry as wasteful and disorganized compared to German systematic efficiency and technological discipline. The technological advantages that German tanks possessed included sophisticated fire control systems, advanced armor protection, and superior mechanical engineering that reflected years of systematic development and combat experience. German armored vehicles had proven tactical superiority through mathematical combat effectiveness. Combat statistics from 1939 to 1942 seem to validate German assumptions about tank warfare effectiveness and technological advantages over Allied armored forces. German panzer units had achieved remarkable success through superior vehicles and systematic tactical application that appeared impossible for mass-produced enemy tanks to match. Strategic planning for prolonged armored warfare assumed German technological advantages would enable victory through superior tank performance and systematic crew training that would overcome any quantitative disadvantages. Quality appeared more decisive than numbers in mechanized operations, where individual vehicle capability determined tactical outcomes. International military analysis recognized German achievements in tank design and armored warfare that had established clear technological leadership in mechanized combat. Professional assessment confirmed German superiority in most armored vehicle performance categories, while documenting innovative tactical applications. Resource allocation within German armored forces prioritized tank quality over production quantity, reflecting confidence that superior performance would achieve victory through technological advantages rather than numerical superiority. Individual excellence justified systematic resource investment in advanced engineering. The Panzer Pride appeared mathematically certain based on proven combat effectiveness and systematic technological advantages that had established German dominance in armored warfare through superior engineering and tactical innovation. William Knudsen, former General Motors president turned director of production for the U.S. War Production Board, walked through the Detroit Arsenal tank plant, observing assembly techniques that would revolutionize armored vehicle manufacturing through automotive mass production methods. The automotive industry executive was applying civilian manufacturing expertise to military vehicle production with systematic efficiency that would soon challenge German assumptions. The M4 Sherman tank program that American industry developed represented fundamental departure from traditional armored vehicle manufacturing that emphasized individual craftsmanship over systematic production. Sherman design prioritized reliability, maintainability, and mass production capability rather than technological sophistication, enabling manufacturing rates that exceeded German calculations. Assembly line techniques that Detroit Arsenal employed included automotive production methods adapted for tank manufacturing through systematic organization, standardized components, and continuous workflow that eliminated traditional bottlenecks. American automotive experience had created manufacturing efficiency that exceeded military vehicle production through civilian industrial expertise. Workforce mobilization supporting Sherman production included unprecedented numbers of women entering heavy manufacturing while maintaining systematic training programs that created skilled workers adequate for complex vehicle assembly. Democratic education systems produced human resources through competitive instruction and merit-based advancement. Supply chain coordination across American tank manufacturing included steel delivery from multiple sources, engines from specialized manufacturers, and components from hundreds of subcontractors whose production was synchronized through systematic logistics management. Materials coordination exceeded German capabilities through democratic industrial organization. Quality control procedures ensured Sherman reliability through systematic testing, continuous inspection, and performance validation that maintained combat effectiveness while enabling mass production rates. American manufacturing had achieved quality through scientific methods rather than individual craftsmanship attention. The standardization that Sherman production achieved eliminated custom engineering and specialized components that characterized German tank manufacturing, enabling interchangeable parts and universal maintenance that simplified logistics while reducing production complexity. Systematic design created operational advantages through manufacturing forethought. Innovation acceleration continued throughout Sherman development as American engineers improved tank specifications while maintaining production schedules. Competitive pressure encouraged continuous advancement that exceeded traditional development cycles while ensuring manufacturing compatibility. Economic efficiency that Sherman production demonstrated included cost reduction through volume manufacturing while maintaining performance standards adequate for combat effectiveness. Industrial competition created advantages through systematic optimization and competitive resource allocation. Training programs for tank crews paralleled production expansion through systematic instruction that prepared personnel for Sherman operations while maintaining professional competence. American military education created human resources adequate for expanded armored capabilities. International cooperation through Sherman production included tank delivery to Allied forces while maintaining American armored requirements, demonstrating surplus capacity that exceeded domestic needs. Democratic values created sustainable assistance through systematic generosity. Strategic planning that incorporated massive Sherman deployment included tactical doctrine development and operational coordination that would maximize tank effectiveness. American military strategy integrated production advantages into comprehensive campaign planning that assumed abundant tank availability. The maintenance infrastructure supporting Sherman operations included spare parts production, repair facilities, and technical services that sustained combat effectiveness under extended operational conditions. Systematic logistics created sustainability advantages through competitive organization. Technology integration throughout Sherman manufacturing included precision tooling, automated equipment, and systematic coordination that enabled consistent production while reducing unit costs. American industrial methods achieved technological advantages through competitive innovation rather than traditional craftsmanship approaches. The Detroit Revolution was creating tank production capabilities that would soon overwhelm German armored advantages through systematic abundance rather than individual technological excellence. March 1943. German intelligence documentation of American tank production revealed manufacturing rates that challenged every assumption about armored vehicle construction and industrial possibility. Detroit Arsenal Tank Plant was completing one M4 Sherman every 75 minutes while maintaining simultaneous production at multiple facilities that collectively exceeded German total armored vehicle manufacturing capacity. The mathematical analysis that German military planners performed revealed American Sherman production approaching 2,000 tanks monthly, while German Panzer production struggled to maintain 300 vehicles across all manufacturers. Enemy industrial capabilities had achieved systematic abundance that violated traditional assumptions about armored vehicle manufacturing complexity and resource requirements. Statistical verification through multiple intelligence sources confirmed American tank production that included standardized components, assembly line manufacturing, and systematic quality control that enabled impossible production rates. Enemy manufacturing had achieved efficiency that exceeded German industrial organization through democratic competitive methods. Photographic reconnaissance of American tank factories revealed production techniques that eliminated individual craftsmanship in favor of systematic manufacturing approaches adapted from civilian automotive industry. Democratic industrial organization had achieved military production through competitive rather than authoritarian methods. Economic calculations demonstrated American tank expenditure that exceeded German military budgets while maintaining civilian automotive production and international assistance programs. Democratic capitalism had achieved resource abundance that command economy methods could never duplicate through systematic efficiency. Supply chain analysis revealed American tank manufacturing coordinated across continental distances with material flows that exceeded German logistical capabilities. Enemy industrial organization demonstrated systematic coordination that exceeded authoritarian planning through competitive cooperation and democratic resource allocation. The workforce demographics supporting American production included women, minorities, and civilian workers whose technical competence challenged German assumptions about military manufacturing requirements. Democratic society had mobilized human resources through inclusive participation rather than traditional military organization. Technology assessment based on captured Sherman tanks revealed manufacturing quality that equaled German precision while being produced in quantities that German industry considered impossible without sacrificing performance. Mass production had achieved reliability through systematic methods rather than individual attention. Innovation integration throughout American production included continuous improvement in tank design and manufacturing efficiency while maintaining production schedules that traditional methods could never achieve. Competitive pressure had encouraged advancement while ensuring systematic delivery. International cooperation evidence included American tank delivery to Allied forces that demonstrated surplus capacity beyond domestic requirements while maintaining production expansion that indicated unlimited manufacturing potential. Democratic abundance enabled systematic generosity. Quality control achievements in mass production exceeded German individual inspection standards, while enabling systematic output that traditional manufacturing considered impossible without compromising combat effectiveness. Scientific approaches had solved quality challenges through systematic methods. Strategic implications of confirmed American production included recognition that German tactical advantages would face numerical opposition that exceeded response possibilities through individual excellence or technological superiority. Quantity combined with adequate quality had achieved systematic advantages. The psychological impact on German leadership included recognition that fundamental assumptions about democratic industrial weakness had proven systematically incorrect. Reality contradicted ideology through mathematical evidence that could not be dismissed through traditional German economic theory. Resource management documentation revealed American abundance that included strategic stockpiling beyond immediate requirements, while maintaining global production commitments that indicated systematic industrial superiority through competitive organization. The statistical impossibility had become strategic reality that forced German acknowledgement of democratic advantages in industrial organization that exceeded authoritarian alternatives through competitive efficiency and systematic abundance. June 6, 1944. The Allied invasion of Normandy revealed devastating effectiveness of American tank production, as over 5,000 Sherman tanks participated in D-Day operations, while maintaining strategic reserves that exceeded German total armored inventory. The mathematical superiority of American manufacturing had translated into overwhelming tactical advantages that rendered German panzer excellence strategically irrelevant. The tactical deployment that Sherman abundance enabled included multiple armored divisions operating simultaneously while maintaining replacement capabilities that German forces could never match, despite individual tank superiority and crew training advantages. American production had eliminated traditional armored warfare constraints through systematic abundance. German panzer commanders discovered tactical situations where destroying individual Sherman tanks achieved no strategic advantage because American replacement rates exceeded German destruction capabilities. Mathematical relationships had shifted decisively toward Allied armor through industrial rather than combat effectiveness. Combat statistics from Normandy operations documented German tank losses that could not be replaced, while American Sherman units maintained strength through continuous production and systematic replacement. Industrial abundance had created tactical sustainability that exceeded German response possibilities. Intelligence analysis by German armored commands revealed American production capabilities that exceeded strategic planning assumptions while demonstrating industrial organization that surpassed authoritarian efficiency through democratic, competitive methods. Enemy capabilities had achieved systematic advantages. The psychological impact on German tank crews included recognition that individual combat excellence could not influence strategic outcomes when facing opponents with unlimited replacement capabilities. Tactical victory had become strategically meaningless against American production abundance. Strategic implications of Sherman deployment included Allied armored capabilities that could absorb tactical losses while maintaining offensive momentum that exceeded German defensive planning. Abundance had eliminated traditional tactical considerations through systematic numerical superiority. Supply chain advantages that American production provided included spare parts availability, maintenance support, and replacement vehicles that sustained combat effectiveness under extended operations. Systematic logistics exceeded German capabilities despite homeland proximity and interior lines. The maintenance infrastructure supporting Sherman operations included standardized components, simplified repair procedures, and abundant spare parts that maintained operational readiness under combat conditions. American manufacturing forethought had created sustainability advantages through systematic design. Training programs that prepared Sherman crews included systematic instruction that produced competent operators through standardized methods while maintaining production schedules that provided adequate human resources for expanded armored capabilities. Innovation acceleration during combat operations included continuous improvement in Sherman design and tactical employment that enhanced effectiveness while maintaining production compatibility. American competitive pressure had encouraged advancement through systematic development. Economic efficiency that sustained Sherman production included cost advantages that decreased as volume increased while maintaining combat effectiveness that exceeded traditional armored vehicle development methods. Democratic capitalism had achieved systematic manufacturing advantages. International cooperation through Sherman deployment included tank delivery to Allied forces that enhanced collective armored capabilities while demonstrating American surplus capacity. Democratic values had created sustainable assistance through systematic generosity. Technology integration throughout Sherman operations included radio communication, coordination equipment, and systematic maintenance that enhanced tactical effectiveness while supporting mass deployment. American industrial capabilities had provided technological advantages through competitive innovation. Quality control achievements in combat validated American mass production methods through battlefield effectiveness that exceeded German individual tank advantages when deployed in systematic abundance. Scientific manufacturing had achieved tactical superiority through systematic quality rather than individual excellence. The Normandy Revelation demonstrated American tank production had fundamentally altered armored warfare mathematics through industrial capabilities that rendered traditional tactical excellence obsolete when facing systematic abundance combined with adequate performance. May 8, 1945. As Nazi Germany surrendered unconditionally, the final accounting of American tank production revealed numbers that had redefined armored warfare. 49,234 Sherman tanks manufactured through assembly line methods that averaged one completed vehicle every 90 minutes at peak production, creating armored capabilities that had overwhelmed German tactical excellence through systematic abundance. The strategic validation that Sherman production provided confirmed industrial mobilization as decisive factor in modern armored warfare, while demonstrating democratic advantages in manufacturing organization, resource allocation, and technological application that exceeded authoritarian alternatives through competitive innovation and systematic efficiency. General Guderian's post-war acknowledgement included recognition that German panzer superiority had been strategically defeated by American production capabilities that exceeded every calculation of democratic industrial potential. Assembly line manufacturing had rendered individual tank excellence irrelevant through overwhelming numerical superiority. Economic efficiency that American tank production achieved included cost reduction through volume manufacturing, while maintaining combat effectiveness that exceeded traditional armored vehicle development. Competitive capitalism had proven superior to command economy organization for systematic military production and technological advancement. International cooperation through Sherman deployment included tank transfers to allied nations that enhanced collective armored capabilities while demonstrating American production capacity beyond domestic requirements. Democratic values had created sustainable assistance through systematic equipment sharing. The educational systems that produced American tank workers created human capital advantages through competitive academic development that exceeded traditional manufacturing methods. Democratic education had produced technological capabilities through systematic knowledge development and merit-based advancement. Technological legacy of Sherman production influenced post-war armored vehicle development through manufacturing techniques, design principles, and quality control methods that revolutionized global tank production. Scientific advancement had created lasting advantages through systematic research and competitive innovation. Quality control achievements in mass production demonstrated American manufacturing capabilities that maintained combat effectiveness while enabling systematic abundance that traditional methods could never achieve. Scientific manufacturing had produced tactical superiority through systematic approaches. The workforce development that enabled Sherman's success demonstrated democratic society's ability to mobilize human resources through opportunity and education rather than coercion. Competitive systems had produced capabilities that exceeded authoritarian alternatives through inclusive participation. Strategic implications of American armored dominance included post-war military leadership that would influence global tactical doctrine through technological advantages established during wartime production. Democratic military power had achieved systematic superiority through industrial organization. Innovation acceleration that Sherman development represented established American automotive industry as global leader in military vehicle production through competitive research and systematic advancement that exceeded traditional manufacturing methods. Supply chain resilience that sustained Sherman production included resource coordination and logistical management that maintained manufacturing schedules despite global commitments and material competition. Systematic organization had achieved efficiency through competitive cooperation. The maintenance networks that supported Sherman operations included repair capabilities, parts availability, and service systems that maintained combat effectiveness under global deployment conditions. Systematic logistics had created sustainability advantages through democratic organization. Medical applications that Sherman Abundance enabled included casualty evacuation vehicles, mobile medical units, and healthcare transport that enhanced battlefield medicine while demonstrating industrial versatility through systematic adaptation. The assembly line victory had proven that democratic industrial organization could achieve systematic advantages over traditional military excellence through competitive innovation, systematic manufacturing, and abundant production that authoritarian systems could never match through centralized control or ideological motivation alone. If this incredible story of how American assembly line tank production overwhelmed German armored excellence through systematic abundance amazed you, make sure to subscribe for more tales of democratic industrial triumph.